Hi guys, I'm Bolt Greywing, and today we're back with another Java coding tutorial. So let's get started. So where we left off, we had added these update and render game functions, which right now they just print out messages. Let's see, so that's game panels. Game panel hasn't changed anything. Oh yeah, it's in the game class. Alright, so it says I'm updating and I'm rendering pixels. So just run that. So nothing really has changed. Okay, other than that. So now from here, well, this is a nice game loop. The problem with it is our update and render rates of the game are always going to be one after the other. So typically you want a slower update game rates for dealing with the game logic and a faster render rate for displaying the graphics to the screen. So in order to do that, I'm going to add a couple of more variables. So int update limit is equal to 60, and int render limit is equal to 200. So what this render limit and update limit are doing is they're setting how fast the game can process each of those instructions for like updating the game and rendering games. And to achieve this, we need a few more pieces of information. So int update cycle is equal to let's see, if I remember correctly, okay, this might need to be a double, I think. Yeah, this definitely needs to be a double. Okay, update cycle is equal to, and we need 9 zeros. So 3, 4, 6, 7, 8, 9, 2, 3, 4, 5, 6, 7, 8, 9. And then we need to divide it by 60. Oh, not 60. We want to divide it by our update limit, which is above, so that determines how quickly we're updating the game. Alright. And then we need a long variable that says that basically is our that's kind of a current time value. It's a time tracker. So we say long update time is equal to system.nanotime, and what nanotime will do is it sets a really big value that our computer can process. So, and from there we need to go into here and say long update long now is equal to system.nanotime, and then we need to, and so this long now, we're going to compare it against our update time. So I say if now minus update time is greater than our update cycle, like so, then we can run whatever's in here. Okay, so we call we move game.update method into here, and then we run that and we update the game, and then we say that not now to that, we set update time is equal to now. Let's see, I might have some of this operations out of order, but I think this is how you do it. Yeah, so it should be like this, and what that allows you to do is it'll now be rendering for that specific limit of time, and we also need to do the exact same thing, but for the render action. So say long render time is equal to system.nanotime, and for this one we use basically the equivalent one and say now minus render time is greater than the render cycle. Oh right, we don't have render cycle yet because I only got it for the update time, so now I have to copy this, and instead of update cycle we call it render cycle, and the render limit is set to that, and now we load this and we go over here and we call game.renderGame, and then from there we say render time is equal to now, and so that should fix up everything here. Let's see, so now we have now minus update time and render time is here. So basically when it finishes rendering, it sets the time back to what it needs. So this code should be functioning properly, and I just removed the system.print line I'm running because we're kind of done using that print statement, right? And for here, now let's just run the program to see how it works. And now we're still running the game, but now we have a render and update, each taking place in different periods of time. So the update cycle is going is only updating every 60 seconds, and our render game function is running at 200. So basically neither of the two are now lockstep, so they've basically been set up in a way that they're independent now. Alright, so on to the next task. Alright, now that we have this set up, it would be kind of nice to kind of keep track of our frame rate. And so to do that, we need another setting that says that basically keeps intact of timers as well, but this one is a little different. So I'm going to leave some space between these two methods. So now we're going to have a long display time is equal to system dot not nanotime dot current time millis, and that's basically our display timer. And for this, we go down here. Let's see. Well, we could do it either before or after we update and render. For now, I'll put it at the bottom. So if display time, hold on. So we're going to do something a little different. So system.current time millis, actually. Yeah, we can do this. Might make more sense, actually, hold on a second. It makes more sense to actually put this in a variable. But for now, we're just going to keep it as this. So system.current time millis minus display time is, and then we say it's greater than, if it's greater than or equal to 1000, let's say. The 1000 is basically indicating 1 second. I'm going to make it a little higher, so I'm going to do it every second, every 8 seconds rather than every second. That'll pull the system information. And one thing to keep in mind that we need to set the display time equal to system.current time millis, because if you don't do that, well, it's always going to be checking this. So we need to reset that. And on top of that, we also need a couple of new variables. So we're going to have int, actually, let's see, short, long, int FPS, we'll call it FPS, is equal to 0, and int UPS is equal to 0, but I'm going to change that into into a short. And so for UPS, we're going to have do UPS. Actually, I'm going to make these lowercase. Just so it's more consistent. Only use all caps if these are going to be staying. Only use caps if it's staying, all caps if it's a constant. Alright, and then for here we say FPS is equal to FPS plus plus. And now for here, when we're displaying, we say we need to reset the frames and the updates, so we say UPS is equal to 0, FPS is equal to 0. So this is our update rate and frame rate, and for that we also need to display the information system.out println, and then we need to print a well, let's see, what do you want to start with? UPS is UPS, and FPS is FPS, and then we click that, and so now when I go to run this, we should get a message on the bottom of the screen that says how quick, what the FPS and updates per second is. Alright, so run game. Okay. Okay, I need to disable this because those two are kind of running a little bit too fast, and just so we can see this might take a little longer. Okay, so let's rerun the code again. Okay. And now we're actually having something come back. So now we see that 479, 1599, 480, 1599. Alright, so as you can see, the information is populating, but it's very slow, so kind of need to reduce reduce this. Let's see. I'm going to Alright, I think, yeah, I definitely need to reduce that. So instead of that, yeah, I'll just make this 4,000, so half of it. So now it should run much quicker. Yeah, that is definitely much faster. Alright. I think I'll call it here. Thank you guys so much for watching. This is Bolt Graywing signing out. Bye bye!